the first instinct when we think about return is how much did I make, right? And this instinctive formula is the HPR, the holding period return. And as you can see, it doesn't care about the time. So if you invested 100 and you get 110, you made 10%. But I mean, was it in 1 year, 2 years, 5 years? In the HPR, it will always be the same. It will always be 10%, and there is no time dimension. But in reality, the time matters a lot. If I give you 110 in 1 year versus I will give you 110 in 10 years, it's not the same at all. They're not economically equivalent. And there are two reasons for that, two main reasons. The first one is inflation. So the purchasing power changes over time. Everyone is feeling it quite a lot those days. But the second reason is probably less discussed or less understood, is the opportunity cost. Money that you don't have now cannot be invested anywhere or elsewhere. So you're losing optionality. And if you look at the formula right here, this is a simplified version of the Fisher equation. And when we see nominal rate, real rate, and expected inflation, at first it might be a bit confusing, like what is the difference between nominal rate and real rate? Well, nominal is in name only, and it represents the money that you will get, or the return that you will get if you were to invest in a risk-free asset, and in the economy is usually the UST bills 3 months. Whereas real rate is what we just discussed before, is the optionality, right? Is the value of the optionality, because the expected inflation is considered on the side. So the real rate is if we are in an imaginary world where there is no inflation, in a year the $100 will be worth exactly the same as today, then because I'm giving up on the choice of doing what I want with this $100 for 1 year, then I want to be compensated for it, and this is the real rate. Now, looking at the example below, you will see that depending on the rate, the discount rate that we use, you will have a different perception or value of return. And if your required return is, let's say, 5%, then in a year the 110 will be more than enough. Your NPV, net present value, which is simply bringing the future value back to today's value, will be positive. But if the discount rate is 20%, right, then you're not losing money in nominal term, but in nominal terms, but relative to the 20%, this investment has a negative NPV. So it fails to meet your requirements of those 20%, and it destroys value compared to your benchmark. If it was the risk-free rate, you could have put this money in UST bills and got 120. In this case, you got 110, which is less, so you're eroding value.